Hello everyone, welcome to this another video in this lecture series. Today we are going to see spherical polar coordinate system. So in this video we will be finding a metric coefficient in spherical polar coordinate system, then scale factors, and after that we will be looking for the unit vectors in spherical polar coordinate system. Okay, let us start with that. What we know is this: u1, u2 and u3 are coordinate in orthogonal curvilinear coordinate system, and E1 cap, E2 cap and E3 cap are unit vector in orthogonal curvilinear coordinate system. Now if we compare orthogonal curvilinear coordinate system with the spherical coordinate system, what we know is that u1 is r, u2 is theta and u3 is phi, right? Similarly, E1 cap will be ER cap, E2 cap will be E theta cap, and E3 cap will be E phi cap. So this is what we are going to do. We are going to find ER cap, E theta cap and E phi cap. Now what we know is this: R, theta and phi are coordinate in spherical polar coordinate system, and x, y, z are Cartesian coordinate. So if we see the transformation equation between r, theta, phi and x, y, z, then we can write it like this: x is equal to r sine of theta cos of phi, then y is equal to r sine of theta sine of phi, and then z is equal to r cos theta. So these are the transformation equation. I will number it 1. Okay, so if you don't know how we have obtained this transformation equation, you can go to lecture 1. Okay, lecture 1, there you can find how we have obtained this transformation equation. Now suppose there is some point P. Okay, this is some point P in our coordinate system. This might be the Cartesian coordinate system or a spherical coordinate system. So x, y, z are coordinate, and I can write the coordinate of this system, this point, like this: x, y, z. Similarly, if I consider that this is a spherical coordinate system, then I can say that coordinates are r, theta and phi. Now if I joined this point P with the origin O, then okay, I can say that OP is a position vector of point P. OP bar is a position vector of point P, and I can write OP bar as R bar, right? So OP bar is R bar, and which can be written as x I cap plus y j cap plus z k cap. So it can be written like this. Now what I will do, I will take this x, y, z in this equation. Let us say it is 2. Okay, so here I can put the values of x, y, z. So I can write r bar as, so here you can see x is, so this is I am taking here this one, and you can see x is r sine of theta cos of phi I cap, right? Then plus y, y is r sine theta sine of phi j cap, plus there is a z, z is r cos theta. Here you can see z is r cos theta, r cos of theta k cap. Okay, so this is the equation. Let us say this is equation 3, right? And now what I want to do, I want to find the derivative of r bar. So what I know is this r is a function of r theta phi. Okay, this is what I know. So if I want to find derivative of r bar, okay, derivative of r bar with respect to r, then I have to write it like this, delta r bar by delta r. You might think I can write it like this, delta dr bar by dr, but I cannot write it like this because r bar is a function of r, theta and phi. So I have to consider theta and phi constant. That's why I have to write it like delta, right? Delta means partial derivative. You are taking partial derivative. Similarly, I want to find a derivative with respect to delta r bar by delta theta and delta r bar by delta phi. Okay, so taking a derivative simply means you are finding a change in that quantity with respect to another quantity, like a change in r bar with respect to position vector r, right? I mean, this is not position vector, it is magnitude of position vector, and then you want to find a change in r bar with respect to theta and then change in r bar with respect to phi. Okay, let us do that. Here you can see if you start taking derivative here in this first term, you can see there is here is r bar, but remaining part is not a function of r. So what I can say, it is independent of r. Second thing, here you can see here is r and again here is r. So from this, if I try to take a derivative, then it will be derivative of r is 1, so I can write it like this 1, and then sine theta cos phi I cap will be treated as constant. Similarly, I will take a derivative of second term. Here again r is there, so that derivative will be 1, and then there will be sine theta sine phi j cap, and then I will take a derivative of third term, which will be cos of theta k cap. You can see there is a r. I took derivative of r with respect to r, which is 1, right? Delta r by r, which is 1, right? This is not r bar, okay? This is r. Okay. So second, I want to take a derivative of r bar with respect to theta. So you can see this term contains sine theta here. Then here is a sine theta, and here is a cos theta. So each term contains theta somewhere. So I will treat r as a constant. Then sine theta, derivative of sine theta is a cos of theta. Cos of phi will be constant because it does not contain a theta, and then there will be I cap plus r, derivative of sine theta will be cos theta. So okay, let us not put a bracket. That will be cos theta, and then sine phi is a constant, j cap. Then third term, you can see there is r is a constant, okay. Then cos of theta, r is a constant means it is constant with respect to coordinate theta. Okay, so derivative of cos theta is minus sine theta, so I will put minus sign here. R was a constant, then r sine theta k cap. Okay, similarly I want to take with respect to phi. Now when I am taking with respect to phi, I will consider r and theta terms as a constant. So let us do that. R sine theta constant, and derivative of cos of phi is minus sine of phi I cap plus r sine theta is a constant, and here this term contains sine of phi, so derivative of sine of phi is minus cos of phi minus cos of phi. Oh, sorry, it will not be minus, this will be sine phi has a derivative cos phi, so it will be like this, cos phi j cap. Okay, so now we have obtained this partial derivative. So next thing will be, I want to obtain the metric coefficient. Okay, so we are interested in obtaining metric coefficient. Okay, so metric coefficients, what we know is this, that G11, okay, G11, G22 and G33 are metric coefficient, and if you want to obtain the scale factor from this metric coefficient, then you can write H1 is equal to root of G11, H2 is equal to root of G22, and H3 is equal to root of G33, right? That is very simple, and we have done it earlier. So okay, let us try to find metric coefficient. So G11 is delta R bar by delta R dot delta R bar by delta R. So if A bar is a sum vector and you are taking, so if it is like this, ax I cap plus ay j cap plus az k cap, and you are taking the derivative of, I mean dot product of A bar with the A bar, that simply means what you are doing, you are taking a square of its magnitude, and you know, if you want to find the magnitude, you will find it like this, ax square plus ay square plus az square, right? This is a very simple thing, and if you want to obtain square, you just square the term. I can do a similar thing here. Here you can see, so delta R bar by delta R, that is here, right? So taking a square, this is like this, you are delta R bar by delta R and magnitude of that and square of that. So you will take square of this term, then square of second term, and then square of third term. That will be sine square theta cos square phi plus sine square theta, second term now, okay, second term, sine square theta plus sine square phi, and then cos, this is third term, cos square theta. Okay, so what I see here, in first and second term, sine square theta and sine square theta is common, so I can take them out. So that will look like sine square theta, I am taking them common, and there is a cos square phi plus sine square phi, right? Here is the sine square phi, and there is a third term which is cos square theta. Okay, so sine square phi plus cos square phi is 1, right? It is 1, and then this will look like sine square theta, this term is 1, plus the second term cos square theta, which is equal to 1, right? Sine square theta plus cos square theta is 1. So what I know now, G11 is 1. This is my first metric coefficient. Now let us do it for second term. Okay, just a moment. Okay, so here is our second term, that is G22 is our second metric coefficient, and that will be delta R bar by delta theta dot delta R bar by delta theta, which will be mod of delta R bar by delta R, which is equal to, so I have to take the square of these terms. So first term is this, second term is this, you don't need magnitude here, and third term is this. Okay, let's square that. R square, not sine, R square cos square theta cos square phi, right, plus R square cos square theta sine square phi minus, but you know if you square a negative term, this third term is a negative with negative sign, so if you square the negative term then it will become positive, and there is r square sine square theta. Now what we see here, r square is common everywhere, then okay, so in first two term cos square theta is a common, so I can take it outside, so it will become r square. First in I'm taking r square common from everywhere, and then I am going to take cos square theta common from first two terms, so it will look like cos square phi plus, okay, sine square phi. I should use a round bracket, okay, so I will use them. Okay, so and then plus sine square theta. What I did here, each term you can see here, each term contain r square, so I took r square, and r square common from here, which is here, and then I took from first two terms I took cos square and cos square theta common, so which is here, and then there is a cos square theta sine square theta which is here, and then the remaining part of third term which is here. I hope it is clear. Now what I see, this is 1, okay, again you see if you add cos square theta plus sine square theta, right, here is a cos square theta, this quantity is 1, this is sine square theta, so it will become r square in bracket cos square theta plus this quantity sine square theta, which is r square, right? See, this is 1, so this is r square. Now I want to find the third metric coefficient. G22 is r square. Third metric coefficient is G33. So G33 is equal to delta r bar by delta phi dot delta r bar by delta phi. Okay, so I know if you are taking a dot product of vector with itself, that simply means square of that vector's magnitude. So I can write it like this, and then I have to go for delta r bar by delta phi. So here you can see, okay, I will carry it here. Here you have this term, you have to square this term, and you have to square this term. So it will look like, I wish I could have more space, so I will write it here. It will look like, let me use a different pen so that it will be more clear to you. It will look like sine square theta, then sine square phi, and then there is a plus r square. See, I am taking it here from here, okay, I am taking the square of that, then sine square theta cos square phi. Okay, so this is what we have got, and let us go down and see what we can take common. So I can take r square, right, and here you can see I can take r square sine square theta common, so this will become r square sine square theta, then sine square phi, and then r square sine theta is a common, plus cos square phi, right? Again this quantity is 1, so I can write r square sine square theta, which is G33, right? So what I see, G11 is 1, here G11 is a 1, G22 is r square, and G33 is, okay, I should, Okay, so G33 is r square sine square theta. Now, why I need metric coefficient? Because I want to find scale factors. So let us do it here. Scale factors. G11 is equal to, okay, I want to find scale factor, so I shouldn't write G11. H1 is equal to root of G11. G11 is a 1, so H1 will be root of 1, which is equal to 1. Similarly, H2 is equal to root of G22. G22 is r square, so H2 is r, and H3 is equal to root of G33, which is root of r square sine square theta, which is equal to r sine of theta. So these are three scale factors which we have got. I will write them here. H1 is a 1, H2 is r, and H3 is equal to r sine of theta. Okay, now we have obtained two things which we were interested in. Third thing is we want to obtain the unit vectors, right? Unit vectors. Unit vectors are er cap, e theta cap, and then e phi cap. You know, if a bar is a some vector, then I can write it like mod of a bar and some n cap. So n cap here is a unit vector. Right? Okay. Similarly, if I want to obtain er cap, then I can write it like this. So I need to, okay, so here let us go further and see. If I want to obtain n cap, I can write it like mod of a bar divided by mod of a bar, right? So this is what I can do. So similar thing I'm going to do here. I will divide delta r bar by delta r by its magnitude, delta r by delta r bar by delta r, right? This is very straightforward. We are just dividing vector by its magnitude so that we will get unit vector. As you know, this is a change in r bar in r direction, so it must be in the direction of r, and that direction is contained in er cap because this is unit vector. Okay, so what I know, delta r bar by delta r, I have to go off so that here you can see. Here is a delta r bar by, okay, let us copy this quantity. So let me see whether I can copy this or not. I will copy it here. Okay, so these are the quantities we are interested in. So you can see delta r bar by delta r is sine of theta cos of phi I cap plus sine of theta sine of phi j cap, and then will remove this. Then plus cos of theta k cap. I have to divide it by its magnitude. As you know, we have already obtained the magnitude, which is above here. See, you took a magnitude square here, right, which was here. You can see it is a magnitude square. So magnitude square is a 1. So which imply delta r bar by delta r square is a 1. That simply means delta r bar by delta r is 1, right? So which I will take here. Here you know that this is 1. So our answer is this quantity. Okay, so numerator is our answer, that is sine of theta cos of phi I cap plus sine of theta sine of phi j cap plus cos of theta k cap. So this is our ER cap. Similarly, I want to work out for, so E is theta cap, right? Okay, let's see what is the magnitude of it. Its magnitude is delta r bar by delta theta. So again we have to go upward. I just want to show you where we have obtained the magnitude square. While so here you can see delta r. Okay, I just wrote here. This is not correct. I should write here delta theta. Okay, so what I know from this, delta r bar by delta theta is equal to r, right? Because here is a magnitude square. Okay, let's carry it downward. So here you can see it is r. Okay, and similarly for third term, delta r bar by delta theta, and mod of that will be r sine of theta. We have done it. Okay, so you can go back and you can take a look at that. Even you can find it here if you take a root of this quantity square of this term and plus this term, you can see r square sine square theta is coming common, and then there is a sine square phi plus cos square phi, right? So this quantity is a 1 and you are getting r square sine square theta and root of that, which is r sine theta. Okay, if you divide this quantity, okay, this quantity, so let us, okay, if you divide this quantity by r, then you can see r goes and r goes with this r, so it will like this, cos of theta cos of phi from here, right, I cap plus second term cos of theta sine of phi j cap and then there is a minus sign, so it will be minus sine of theta k cap. Okay, similarly I want to obtain for, so here I will write explicitly what I did. When I wanted to obtain E theta cap, I just divide this quantity by its magnitude. Okay, its magnitude, which is delta r bar by delta theta. Similar thing I can do here, delta r bar by delta phi. This will be equal to E phi cap, and this quantity is r sine of theta, right? This quantity is r sine of theta. So I will divide. Okay, just let me clear some so that it will look nice. Okay, so just a moment. Okay, so let us divide it by delta r bar by delta phi mod of that, which is r sine of theta. So if you divide it by r sine of theta, you can see sine theta goes, and r goes here, sine theta also goes. So the third equation will be, I will write it here, delta, okay, e phi cap, which is equal to, here first term is sine phi I cap, and then second term is plus cos of phi j cap, and you shouldn't forget there is a negative sign over here. So this is, so we have obtained our third quantity, that is unit vectors in spherical polar coordinate system. Okay, for today we will stop here. In next lecture we will try to obtain I, J, K, okay, in terms of ER cap, E theta cap and E phi cap. That is very simple. Okay, so let's do it in next lecture. For today we will stop here. Thank you.